Hi everybody, Val Mosier here with Roper Mountain Science Center. Today we're going to talk about electrical energy and electrical circuits. So I want to start out with this cool thing that's on the table, which is a plasma ball. Now the plasma ball works by creating some electrical energy or electrical current kind of inside that sort of center ball. What we're going to do is we're going to take a little close-up view of it. Okay, good. All right, and you can kind of see that ball inside. Now you can see it kind of responding to my hands. I'm going to adjust the lights in just a second so that we can see that a little bit better. But I want to tell you what we're trying to do. We're going to try to light up this light bulb, okay, which is not connected to anything, using the energy from the plasma ball. So, all right, so I'm going to adjust my lights a little bit. There we go. All right, looks kind of cool, right? You see, it almost looks like lightning, right? So that energy is trying to find a path or a way out of our sphere. So if I contact the ball at the top, all that energy is going through my hand and finding a path out. Now I'm going to kind of do it from the back or the side so you can still see my hand, and you can see that energy kind of responding. I'm going to spread my fingers out there so you can see it a little bit better. All right, guys, now if I take my hand off, all right, there's no path for it to escape from. So how do we use this to light up our light bulb? Well, we're going to take our light bulb and we're going to touch it to the top of the ball, the plasma ball, and let's see what happens. Ooh, okay, good. So our light bulb lit up. We can see that that energy comes up to the top of the ball. We're touching the light bulb to the glass on the plasma sphere, and that energy is exciting all those atoms inside this fluorescent bulb tube, and it's creating light. Now, the light is stopping right here at my hand. So what I'm going to do is I'm going to move my hand farther down. Let's see what happens. Ooh, we get a longer path of light. Let's go even farther, the whole way to the end this time. All right, and we can see that that light now, and we're lighting up the entire light bulb. So we're taking that path even a little bit longer. It's starting from the plasma sphere, all that electrical energy coming up through the light, and then it's going back down through my hands. All right, so we're creating a path for the energy to flow. Now, I want you to make a prediction. I'm going to lift the light bulb off of the plasma ball and make a prediction, guys. What do you think will happen to our light? Okay, here we go. Let's see what happens. And yep, our light went out. You probably predict that, and we touch it. Okay, the light comes back on. We complete that path. All right, if we break that path, the light goes off. All right, so I'm going to adjust my lights one more time again. All right, guys, so today we're going to focus on how to use electrical energy in different ways. Here we used it to transform energy into light. We can use electrical energy and electrical circuits to transform electrical energy into sound, motion, and heat. So let's explore that with something we call circuits. Okay, so circuits are going to be our way or our path to create that path for electrical energy to flow. Now we need some basic components in a circuit. We have our battery, which is our source of energy. And then we have wires, which are going to pass the energy along, okay, have a path for the energy. And then we have the light, which is what's going to be using or transforming or changing the energy in the circuit. So, let me put my light bulb label here. All right, guys, so the thing is we want to get our light bulb working, but it's not working right now. So let's see if we can connect everything together. Just like we did with the plasma ball, we had to have a path. So let's use these wires to create a path. We're going to connect it to the light bulb. I bet you guys can make a prediction about what's going to happen. Let's see. Okay, and our light bulb lit up. Okay, so, oops, sorry, my board is moving here. All right, so we have all the parts we need for a circuit. We have our battery, our source of energy. We have, and that energy is being pushed through the wires, right? And the wires are conducting or finding a path for that energy. And then we're using that energy here to produce light. Okay, now notice we have a complete path, all right? And it's called a circuit. If I kind of spread this out, you guys can probably see it almost looks like a circle, right? So that word, right? Circuit, circle. All right, so very similar. All right, guys, now, question for you. I want you to think about this. I'm going to disconnect the battery right here. So I want you guys to make a prediction as to what's going to happen to the light. Will it stay on or will it go out? Okay, so I'm going to disconnect it right there. Light on or off, let's see what happens, and okay, our light went off. I've created an open circuit or a gap in the circuit. For energy, electrical energy to flow, we have to have a complete path or a closed circuit. Now, when you guys use lights at home, you don't have to go into the walls and connect things and disconnect things, right? We have things called switches, all right? And a switch is something that either allows the energy to flow, okay, or it creates a gap to stop the energy from flowing. So let's put a switch in our circuit. We're going to connect it in so that we have one big path. All right, now let's see what happens to our light in our circuit. Okay, push this all in here so we can see it. All right, guys, so our light's not on yet. That's because our switch is open. There's a gap in the path here. So let's close the switch and our light, it's just off the camera view there. Sorry, let's flip it this way so you guys can see it. All right, so our light is on. So if I open the switch, what do you think is going to happen to the light? Right, the light goes out. Our path is broken. This is a open circuit. All right, we're going to close it again and the light goes on. So we've got to have a complete path for energy to flow. Now in this circuit, we were using the energy to we're transforming that energy to produce light. We can also use circuits to transform energy to produce heat. All right, so we're going to show you a way to do that with some very special material that we have. So let's take a look at our circuit here. I'm going to zoom back out. Oh, wrong way. Zoom back out just a little bit more. Okay. All right, guys. So battery, source of energy, wires, which is conducting the energy or creating a path for the energy. And then I have this special material kind of in between. Now, complete path, no gaps. This should be a working circuit. Well, how do we know it's working? Well, this particular material in our circuit is something called graphite. Now, you're familiar with it because it's the same material that is on the end of a pencil, right? So when you write, you leave the graphite behind. That's what makes the marks on your paper. Sometimes we call it the pencil lead as well, but it's a special material called graphite. Now, this material, it conducts the energy, which means it lets it flow, but it also does something very cool. So we're going to take a look at that on our special camera. All right, so there is our special camera view. Now, you can kind of see all of our wires here, right? Here's our battery back here. Here are the wires, and here's that special material. Now notice what color it is. Notice how the things in the table, or gosh, even my fingers, look how cold they are. So these kind of blue dark areas are things that are cold. So what do you think the red means? Well, you're right. That means it's hot or it's warm, right? Even our wires have a little bit of yellowish reddish to them. All right, guys, so we can use electrical energy to produce heat. Now, notice how cold my hands are. Okay, I'm going to touch this warm spot here. I'm going to hold it for a few seconds. And let's take a look at what my fingers look like after hanging on to it for a little bit. All right, so you can see that energy, the heat from our graphite material, was able to heat up my fingers, at least the two where I was touching it, right? So you find things like this at home in your toaster, for example. If you look inside there, there's a little metal filament that heats up and turns red, and that makes your bread nice and toasty. Or a heater at home works the same way, where electrical energy runs through wires and uses special material to give off heat. Now, it's not graphite, but it's the same idea. All right, guys. Awesome job. All right, now what we're going to do is we are going to see if other materials are good at passing the energy through a circuit, and those materials are called, let me slide this way just a little bit, are called conductors. So our graphite allowed the energy to go through the circuit, so it's a good conductor. All right, now the materials that stop or slow down the flow of energy are what we call insulators. So let's do a little test. I want to test a few common materials. I'm going to put these right in the middle of our tray here. I want to test each of these in the circuit and figure out if they're conductors or insulators. So what I'm going to do is I'm going to put my light, a little LED light, in the circuit so that we know whether the circuit is working or not. All right, so if I touch here, all right, we have a complete path. Our light is lit up. All right, source of energy, wires, we're good. All right, now I'm going to just adjust this so it's a little bit in the slightly darker spot here of our screen. All right, let's take a look. All right. It's showing up, not as bright. There we go. Okay. All right, so I'm going to leave a gap in the circuit. Light goes out. Let's start with the first material. This is a drinking straw. Okay, so I'm going to put that in the path, in the circuit. You guys make a prediction what's going to happen. Is the light going to turn on or is it going to stay off? All right, here we go. And all right, our light did not turn on because this material is stopping the flow of electrical energy, or we would say that it's an insulator. Okay, now let's try the metal paperclip. All right, I bet you have a prediction about this one. So let's put it in our path. And let's see what's happened to the light. Oh, if you guys guessed that our light would be on, you are correct because it is conducting or allowing the energy to move through the circuit. So our paperclip, which is metal, is a conductor. I do want to point out our wires today, though. They have plastic on them right here around the clips. But notice the part that's sticking out? Okay, that's metal. So when we connect them and we touch metal to metal, all right, we allow the energy to flow and our light goes on. Okay, all right, now I want to try one more. This one seems a bit tricky. It's one of those little fuzzy sticks. So, do you think our fuzzy stick is going to be a conductor or an insulator? Let's test it and see. All right, so we're going to put that in the circuit. All right, I'm going to give you a second to make a guess. Conductor or insulator, which one? All right, let's see. What? Our fuzzy stick is a conductor. Well, that's because if you look closely at a fuzzy stick, it's actually a metal wire inside. So a lot like our paper clip, all right, the metal is a great conductor of electricity, and we can see that our light is on with our fuzzy stick in the circuit. All right, so good job if you predicted that. And we're going to put fuzzy stick in the conductor category. Okay, awesome, guys. Now, what we're going to do now is, now that you guys are all experts on circuits, I'm going to see if you guys can help us with a problem that we're having. So we're having a problem with our house. Okay, so our house has some circuits in it that make different things work. So we need to have a circuit that turns the light on in the bedroom. We need to have a circuit that's working that turns the fan on in the living room, and we need to have a circuit that's working to turn our kitchen buzzer on to make a sound. But none of them are working now. Can you guys help us with this? I hope so. All right, so what we're going to do is we're going to look at each room, and we are going to figure out if there is a problem with each of the circuits. So we're going to take a close-up view of our bedroom circuit. Okay, there we go. All right, now here's what I'd like you guys to do. I'm going to give you three choices. Our light is not working. Okay, so something must be wrong with the circuit. So here's your choices. Is a switch open? Is there a gap in the wires? Or are we missing an energy source? So let me go over those choices again. Is there a switch open? Is there a gap in the wires? Or are we missing an energy source? So it needs to be one of those three choices. All right, so I'll give you a second or two to think about that. All right, let's take a look. Our switch is closed. Okay, so it's not that. There's no gap in the wires. Everything's a complete path, but I don't see any energy source. There's no batteries, there's no source of energy. So we must be missing our source of energy. So let's put an energy source in the circuit and see what happens. What? Good job, guys. Our light bulb is on. So you guys did a great job, and you got our light bulb working in our house. So we're using that electrical circuit to transform that energy to produce light. All right, good. So we have our light in the bedroom working. Now, let's see if we can get that ceiling fan working in the living room. All right, so here is our living room circuit. So let's take a look at everything. There we go, adjust it there. All right, guys, so same choices as before. Is there a switch open? Is there a gap in the wires? Or are we missing an energy source? So those three choices. So take a look. Is the switch open? Is there a gap in the wires? Or are we missing an energy source? All right, I bet you have figured it out. So let's start with the switch. Switch is closed, that's good. I see we have an energy source, a battery here. There are two batteries. But look, there's a gap in the wires here. So let's close that gap and close this circuit. Right now it's an open circuit. And what? Awesome. We're able to use this circuit. We use a motor to produce motion with our fan. Awesome. So you guys did a great job with that. And you got our ceiling fan working here in our house. Awesome. So lights on, ceiling fans on. We still, though, don't have a buzzer working in the kitchen. All right, so let's take a look at our third circuit, our final one. All right, and let's see if we can figure out what's wrong here. Okay, so we have three choices. A switch is open, there's a gap in the wires, or we're missing a battery. All right, guys, so take a look. I'll give you a few seconds. All right, let's take a look at each one. Okay, let's start with the switch. The switch looks like it's open. I bet you guys figured that out, but let's double check and make sure there's no gap in the wires, everything's connected, and we have our source of energy, so I think that might be it. Let's try it. You guys are exactly right if you guessed that it was our switch. All right, so it's a little louder on this one, on our actual house. All right, so good job, guys. You used and fixed that circuit so we can produce sound, all right? So I'm gonna turn that one off. I have a switch in the back. All right, guys, so good job. We used our circuits and we fixed the problems to use our circuit to generate light, generate motion with our motor, and sound with our buzzer. Okay, awesome job, guys. You did great with that. Thank you for helping us with our house today. All right, now, I kind of want to wrap everything up, and I have this super cool thing right here. What? Ooh, that's kind of weird. Maybe we should take a close-up view of that. Okay. I like this thing. It seems like when I touch it, or maybe it's when I put it down on the table, we see something happening here. All right, so there's metal here, there's metal there. I'm touching here, and I'm touching the metal again, and guys, something happens. Those lights are lighting up. You can hear the sound. All right, interesting. Well, we must have a complete circuit, and I'm going to just show you guys. There's some batteries. Oh, let me come down here. There's some batteries in there. That's the kind of silver discs. And then there's the black part. Let's shake that forward, which is our buzzer, just like the buzzer we had for our kitchen buzzer. All right, but it seems like when I touch here and here, everything starts working. So my question for you is, what is conducting the energy to make this circuit work? Is it the air? Is it the table? Or is it me? My hands? All right, I bet you guessed it, right? It's my hands, right? It's me. So I am a great conductor of energy, especially electrical energy. And when I complete the circuit, that energy is flowing through me. Now, I'm mostly made of water. Water is a great conductor, which is why we tell you guys to stay away from water when there's a lightning storm or electrical storm outside. But I am a great conductor, and I'm completing the path, okay? Open circuit, closed circuit, to make our little energy tube work. Okay. All right, guys. Awesome job. Thank you for joining us for learning about electrical energy and exploring electrical circuits today. We hope to see you back at Roper Mountain soon. Thanks for being with us. Bye.